Hello everyone. Today we are going to see how to estimate chemical properties using Aspen Plus. Chemical properties in the sense the properties say density or viscosity uh, or any of the other properties specific etc. And the other properties like TXY and the PXY, that is we can say the mixture properties using Aspen Plus. Now, what are our traditional approaches? Traditional or conventional approaches. So, first of all, we decide which component or which chemical mixture or which compound or which pure, or I mean, pure component we want to calculate properties of. Then we see the temperature and the pressure range in which we want its property. Once we decide it, later on we move either to equation of state or any of the other experimental or the empirical equations, or from the literature we pick up its property value, say density or Cp etc. Or when we select equation of state, then at that point it becomes very important for us to find its specific volume. Then we can find it specific volume with the help of with the help of some of the equations, starting from k value, that is y is equals to xk, and then we calculate its value. So those are the long calculations. Usually when we calculate it, we usually solve equation of state uh, by converting it into the third degree polynomial, and we again take some constants from the literature, say critical temperature, critical pressure, then eccentric value. And if the system is kind of much more non-ideal, then we also take its uh, uh, act, fugacity coefficients, etc. So this is our conventional approach. Then if we have this one, a very well established conventional approach, then why do we want to go to Aspen Plus? So even so the very first point which I have mentioned here at the bottom is calculating the properties in Aspen Plus is very easy. Just by clicking some buttons, we will be able to calculate the properties. We are supposed to just select what chemical we want to have properties of, then what are the equation of states which we are supposed to use. That too, we actually there is some literature background which we require particularly here, choosing which equation of state we need to select. And in some of the softwares like ChemCAD, we directly get equation of state once we select the compounds. Unfortunately, in Aspen Plus we cannot do that, but Aspen Plus provides an assistant with the help of which we can select equation of state that we will see there. And uh, and so as I said, that the method in Aspen Plus is very simple, as compared to what? As compared to the conventional approach in which we do coding with the help of the MATLAB and the Excel sheet. And in those, what do we solve? We solve third degree polynomials in case if you want to have solution properties. And what are those third degree polynomials? These are nothing but, as I said, equation of states. And in addition to that, sometimes we also solve Rashford-Rice equation, and that is the equation in which we, if you remember, then uh, we solve liquid to vapor ratio, and then we also have k value, and with the help of that we solve that equation, which is, I mean, the solution of this particular equation is similar to solving this third degree polynomial. So this part is, this all these 3 points are kind of conventional ways, and this one, as against of this Aspen Plus way or ChemCAD way or any of the simulation based way, um, this particular last point, Aspen Plus way, is kind of very simple as compared to this one. So therefore, I put this topic why Aspen Plus. So this is why Aspen Plus. So in this activity, what are we going to do? First of all, we will, actually there are only two things, right? First is if there is a pure component, say in butane, how are we going to do? How are we going to estimate its properties? If there are some more components, that is nothing but so I haven't mentioned any component here. So let it be any mixture, say A and B. Those A and B would be anything, ethanol and water, let's say. So if those two mixtures will be there, then what would be its mixture properties? So see, mixture properties would be like thermodynamic properties or say transport properties. And what would be its Txy and the Pxy, that is binary properties, that is Txy, Pxy diagram, etc. So let us go to Aspen Plus environment. So we are supposed to just start Aspen Plus. We can close this. We can click on this and it will also get vanished. Actually, there are two instances which I have started. So let us start again from a blank simulation. We will click on create, and meanwhile I will also close the another one which is started. Okay. So once this will be started, this is a usual window in which we are in a properties mode. So initially we are going to do this one in butane properties. So I will write here butane. By default, when you click, when you write the name of the compound, by default it should be with the a longer chain component. So here it's like n-butane. N-butane is sufficient for us. So we will click next button. In the next, we are again supposed to select which is the equation of state. So right now I will be selecting Peng Robinson as it is mentioned, or we will just check it. Okay, it is Peng Robinson. So I will write Peng Robinson. Once this is selected, I will not go to the simulation environment now. Now once we have added this one, if you will see on the right hand side, there is a tab of pure which is getting activated now. Before adding component, it was not activated. Now it is activated. I can simply click here, and now whole plethora of all the properties are here. Instead of uh, thermodynamic and transport properties, I will click all, because in all I will get rho as well as Cp and everything, and viscosity, all the properties would be there. If I would have just activated transport, then only viscosity would have been there, but now all the properties are here. Let's say I want viscosity, that is mu. So here it is mentioned as mu, so here it's mu. If I will click on that, then say it's the unit is Cp, then liquid is okay. If I need to select butane as like this, then I can change temperature ranges and the pressure here. We can do that. So I can run this analysis, and you can see all the values of viscosities in the range which we have provided is there. So we can easily see and we can easily understand that when the temperature was low, the viscosity was high, and as temperature is increasing, uh, in understanding perspective, the fluid is becoming less and thinner, and because of that the viscosity is reducing, right? Now at any point I can click on show tracker, and I can have any value of any point like this. And even if I will click on pure one here and on the result button, I can see each and everything. We can copy this value and we can paste in our Excel sheet, etc. So this is how we can actually estimate values, that is nothing values of the properties. We can select any property from here. We would have other other available components. So this is nothing but a pure property. So if instead of one I would have two components over here, then I would be requiring to provide its uh, mole fractions or the mass fractions to see its mixture property. Now we can see here that right now, since there is only one component, binary and the mixture, again these are the buttons provide and the ternary diagrams, etc. So these are the buttons provided to see the mixture properties, right? They are not activated yet because only one component is there. Now let us delete this. Okay, I have deleted this. Then let us again go to specification. Now I would like to mention that it is not required to delete. It is not required to delete. I just, I mean, I just deleted it, so no problem with that. Let us add two more things: ethanol and water. And to your surprise, now the binary and the mixture buttons are activated along with the ternary diagram. If there would be only two ethanol and water components, let's delete this row. You can see that ternary and residue curves, which are for more than two components, are not activated, but the binary and the mixture are activated. Right now, the ethanol and water are there. Now I can again simply click on here binary mixture, binary thing. Now binary, we know that binary is for plotting txy and the pxy. Again here mole fraction is given. We can vary ethanol and water, and we can have something which is supposed to be constant. When we want to plot txy, then of course pressure is supposed to be constant. When we have pxy, pressure is supposed temperature is supposed to be constant. And when we have Gibbs energy, again I can have uh, this will not be just one plot. This will be having many lines, say at particular pressure and many temperatures, etc. So let us first of all see our simple thing, pxy diagram. In, let's say, pxy, we want to plot it at 50 degrees Celsius, and the mole fraction is by default, which is the component which is there uh, at the top in the specification will be mentioned here by default. I can also change it to water. Now let it be, and I can easily run it again simply to see. We can see that the pxy diagram is somewhat strange at 50 degrees Celsius. At this point, if I will again show the tracker, at this point, at some 0.71, or I can see that this in result section. These are mole fractions, right? Binary analysis. If I will just click 25 degrees Celsius, and so better, I will just take txy and our very normal condition. If I will run the analysis, the diagram is something different again. So what is the problem? The problem is with the property method. The property method which we have selected. So we can write a conclusion here. Property method which we have selected is kind of not appropriate. So what is the method which we are supposed to select? So that should be inertial. Why? Because water is there, and there are actually two liquid phases. So again we will go to specification, and here I can select inertial, right? I will click on next. There are some of the coefficients which were not there while doing calculation of Ping Robinson. Now this is something different equation of state. Equation of state. I mean modified version of the PV is equals to nRT's ideal equation. Again, I will go to binary. Now we will see whether things are changed. I have clicked on run, and now you can see this is somewhat making sense. Why NRTL is supposed to be selected? Why not Ping Robinson? It has some other reasons, and that I will explain on some other day. But right now, you can see that this is how we can see from TXY diagram that from this mole fraction to somewhere here, the mixture is separable by distillation column, but beyond some concentration, sorry, beyond some uh, mixture composition, the things are not getting separated. But the thing is, this is a TXY diagram. These are old diagrams which I'm closing, right? And I will again go to home, and again I will go on binary here. So these are more binaries. I can just close these all diagrams or delete the other things. The option is there in analysis, right? So I can just click delete. Okay, binary input, and then I will again run analysis, and I will see the TXY diagram. Now, instead of TXY, you can also see PXY. As I said earlier, at various temperatures, say at 50 degrees Celsius and 25 degrees Celsius. Again, I will run the simulation, and I will see the two different plots at two various temperatures. So we can clearly see that if I will elevate somewhat, if I will elevate the temperature, this one is elevated temperature, this one is at 25 degrees Celsius, this is at 50 degrees Celsius. Separation is somewhat becomes easier, right? Because the gap in between these two increases. Okay, these are about TXY diagrams. What about the mixture? If I will click on mixture, then in mixture, I need to actually uh, select the composition. Say 0.5 and water again 0.5. So this is fraction which I need to mention, right? Because if I will not mention this, if I will not mention this, then if I will not mention this, then actually I need to calculate properties, say property of density. Then if I will not mention the fraction of the ethanol and the water, then calculation of density becomes inappropriate, right? Now this property can be on this ranges, so that is something different. Let's say I want to create new thing, say PS5. Now this PS5 which is selected over here can be anything, say heat capacity of mixture, and say anything, like I mean any property, say not mole flow rates, let's say mu, I don't know, mu is there, yes, viscosity of mixture is there. You have specified more than one physical property. Aspen Plus will calculate all properties using all valid combinations. To avoid this, select only one physical property on one side, because this is so obvious, right? If I will select two, then it will be having viscosity at that particular point, and then for that particular point everything, and then again viscosity at another point. Better I will be having just viscosity. I will click this, click OK, and I will again run the analysis. Oh, there is some error. It looks like there is some error. No problem. I will again try running it. I don't know what is the error. Okay, no problem. There is some error. I don't know what the error is, but okay. Let's say uh, let try increasing the temperature range. Pressure would be say 2 bar, and then again I will click new PS6. then I will write Cp. I don't know, Cp will be there, yes. Heat capacity of mixture. Again click OK. Then if I will run analysis, okay, yes, Cp increases at some point of time and then decreases abruptly for this particular mixture, right? Maybe the phase would be changing from this point to this point. I mean, any condition, anything would be there, but this is the property. Then I can again take this PS5 and then again make this PS5 here, because PS5 we know that it is the viscosity. I need to just see whether that again is being shown or not. Again there is some error, so maybe viscosity would not be a good idea uh, because of any reason, I don't know, but this is a way to calculate or to get the properties of the mixture. Let's say I am defining something else, uh, maybe rho, that is density of mixture. I don't know again this will be shown or not, but that's how we can do. I will run analysis. Yes, again for a particular range there is decreasing density, and suddenly the density decreases from I need to start the tracker from a particular value of uh, 0.02 mole gram per cc to very less, I mean very less density. That shows that at this temperature, and I mean at this condition, that is 2 bar and uh, 90 2 bar and 96.19 degrees Celsius, the phase is getting changed, right? That is the thing, right? I would We can also see if we can see the phase change. We can see anything like uh, phase or something. Molar vapor phase fraction, that would serve our purpose to, because we actually want to see what happens at that condition, right? And I can again run the analysis. Yes, we can clearly see that at this point the mass fraction in the vapor suddenly increases to a value. If I would have taken more points beyond 100 degrees Celsius, I could have seen easily the mole fraction converting from 0 to 1 in the vapor fraction, right? So this is how we can confirm that the properties which are calculated over here in this particular section of this tab, pure binary and mixture, etc., are correct. And this is how we estimate the values. So finally, thank you.